let's see the example. So guys, all my notes will be handwritten notes, but always they will be legible. It is very easy for you to find each and every word to understand. A man is standing on a weighing machine. Okay, fine. He is very fitness freak and his weight is found to be 80 kg. You guys can now correct me. This is not weight. Actually, this is mass. The units of weight is in newtons, but the mass will be in kgs. So his mass is 80 kg. If the weighing machine has a surface area of 400 square centimeter, what is the pressure acting on the machine? You can see here, they will ask us the units. He wants the pressure acting on the machine because of this guy standing over this weighing machine in terms of PSI. So I always suggested what is PSI? P means pounds, S means square, I means inches. Pounds per square inches. That is pound force per square inch to be very precise. Remember this. So here a guy is checking his weight over a weighing machine. Because of this weight, a force will be acting here, and because the weighing machine has some area, it has some area. So what is pressure? Pressure is nothing but force by area. So let's see how to solve this. What are the hurdles we'll face here? So pressure is equals to force by area. Very clear. What is the force acting here? The force is due to his weight. So the force is equal to weight in this case. Fine, very clear. What is weight formula? I have shown you there in the top page. It is mass into acceleration due to gravity. So what is his mass? His mass is, this is 80 kgs. Okay, I have taken it 60, no worries. So let's change it to 60 for our convenience. So I have taken mass as 60 kgs and G, it is 9.81. Remember this, the acceleration due to gravity in terms of meter per second square is 9.81. So if I do mass into acceleration due to gravity, then I got 588.6 kg. So since mass is in kg and G is in meter per second square, the finally I have placed all the units at one place. Remember, while doing any calculations, any subject, any numerical, never forget to place the units for each and every term. And always at the end, always simplify the numericals and keep all the units aside at the last. So it is kg into meter per second square. So what is kg into meter per second square? If you go into handbook, you can see here kg into meter per second square is nothing but 1 Newton. 1 Newton is equals to 1 into kg per meter square second square. So you need not to worry again. I have taken it from the handbook. After you get this unit, go to the handbook. This is my handbook here. Just zoom it wherever you want and search it. If it is there on this side or it can be on either side. So keep on checking. You will come to know that it is somewhere here. Where it is. So it is here. It is kg into meter per second square. You got it here. What it is almost equal to 1 Newton. It is just nothing but it's a Newton. So what I did here, I replaced this factor, this unit by simply 1 unit, that is 1 Newton. Okay, using the handbook, I came to this step. Now, what I am doing, I am converting into pound force in the next step. So your question will be, you got the answer in newtons. For the weight, you got the weight in newtons. Why you have voluntarily converted it into pound force? What is the need? Because why n is converted to pound force. My notes will be having all the details, whatever the questions for a beginner that can be raised, all will be mentioned here. Since the required answer is in pounds per square inch, so pounds will be in the numerator, inch square will be in the denominator. For the numerator, it is a pounds is nothing but force. It means that question is hinting that the force which you are finding should be in pound force. That's why even though I got the weight in newtons or the force in newtons, I will convert it into pound force. So how to convert this newton into pound force? Go to the handbook again. In the same handbook, you can see that 1 Newton is equal to 0.225 pound force. So, but since I have this much amount of Newton, as I said, you just need to multiply with this factor here. Then you get the answer in pound force. So multiplying these two, some of you guys might be holding the calculator or you might be having the mobile. You just open it and multiply these two, you get the answer as pound force. Now, the pressure is equals to force by area. We want finally the pressure. And the first step is to find the numerator, that is force in the pound force. So we got the force in pound force, clear. Second case, area. The denominator as area. The area in the question, what they have given? It is given that 400 square centimeter. It is in square centimeter, but the units is inch square. So or square inches. So I want to convert into inch square. Let's see. There is one more important thing to be noted here. 400 square centimeter, fine. Square centimeter is nothing but centimeter square, fine. Now I want to convert into inch square, fine. So what is 1 centimeter? Go to the handbook. I'm facing a bit difficulty in zooming. Okay, 1 centimeter is equal to 0.394 inch. So since I want to convert centimeter to inch, I will multiply the factor 0.394. Then you get some answer. Is this step correct? So
Okay.
since it's an area, since it is a centimeter square, you can see that the centimeter has the power 2. So the factor should be also powered to the 2. So this step is not correct. The correct answer is 400 into 0.394 whole square. You have to square the factor also. So this has to be, it is very important. This is a danger zone. You can do the mistake. So don't forget to square the factor if the initial unit is in square. My initial unit is in centimeter square. So to get the final unit, you have to multiply by 0.394 whole square. So that is the thing you have to remember. Now, the next step is very simple. The final step is force by area in pound force by inch square. You will get the answer as 2.133 pounds per square inch. So that is how you have to keep importance on units and conversions, and handbook has very clearly mentioned all the conversions. Coming to the next case.
Facing the challenge of the FE exam, looking for a way to prepare smarter, not harder? Bhavanam's C2C has the answer. Introducing Bhavanam's C2C FE exam preparation program, designed for civil engineers aiming to pass the FE exam and excel in the USA. Wondering what sets us apart? Our expert team. Meet Mahendra, EIT and project manager, who knows the FE exam inside and out. K.N. Mathur, EIT and civil engineering master's graduate. And Chandra Bhartan, IIT postgraduate and top 422 GATE rank achiever. These experienced instructors have already helped hundreds succeed. Will you be next? In just 3 months, you will master all 14 essential subjects through live online classes held every evening from 8:30 to 9:30 p.m. Monday to Friday. But that's not all. For each subject, sharpen your skills with 15 dedicated practice questions and follow up with quizzes containing 45 questions to solidify your understanding. Prepare like a pro with 3 full-length, 6-hour mock exams designed to mirror the final exam. Plus, receive personalized guidance through one-on-one sessions with our expert instructors to refine your strategy. We understand balancing work, life, and studies can be challenging. So we have got you covered with 1 year access to recorded sessions and replays of live classes to catch up anytime. Here's the game changer. While others charge over $1,000, we are offering everything for just $350. Want an even better deal? Contact the number below now to claim a flat $50 discount and get it all for only $300. Enjoy a 100% refund if you are not fully satisfied within the first week. No questions asked. Our live batches starts fresh every month on 15th. Don't miss your chance to join. Limited seats available. Contact the number below to secure your spot and get enrolled today.
Let's see the second example. And here, this example will clear you some difficulties that we face with the US versus SI units. So please be attentive here also again. So let's see the question. If a man pushed a trolley having items of mass 70 kg and trolley. So here, even in the FE exam, in the question, the units can be in SI units as well as in pounds. It is his choice. He can use any units. In this question, the mass is in SI units, but you can see the answer he want is US units. So he can ask it any way. The given data can be in US, the answer can be asked in SI, or the vice versa. So you guys might be very thorough, might very clear to convert in to get the answer in any unit. So in my question, the mass is in 70 kgs, which is SI unit, and he pushed the trolley, and the trolley has traveled with an acceleration of 10 meter per second square. Again, it is an acceleration with SI units. What is the force applied by the man on the trolley? So he's saying that they went to market. So in US there are some big markets. I forgot the name, like DMart in India. So he applied some force here. Because of application of some force, this has underwent some acceleration. So that acceleration is 10 meter per second square, and the weight mass of entire objects here is 70 kg. So what I'm asking here, my primary purpose, my primary target is finding the force. And the primary formula, the force is nothing but mass into acceleration. Now, okay, you know the formula, they have given the mass and acceleration. Can get the answer. There are two approaches. What are the two approaches here? The first approach is using each term of the formula in the SI unit. So you take this in kg, you take this in mass per axle meter per second square. You find the final term. Our final term is force. You find the final term in SI units. This will be in newtons. If you do this in SI units, this will come in SI unit. SI unit for this will be in newtons, and then finally convert it into the answer, whatever unit he want. If you want the unit in pound force, I'll multiply with this factor. So first, let's proceed with the approach one. The mass is 70 kg. Okay. Acceleration is 10 meters per second square. Both are in SI units. This is in SI units. And I take the formula again. I substitute the each term with the corresponding units. As I always say, don't forget the units. So this is kg here. This is meter per second square here. And I have shown you in the previous example, this term is nothing but 1 Newton. So 70 into 10, 700, it has become newtons. Now, in the previous example, I have shown you to convert 1 Newton to pound force in the handbook. If you want, I will go to the handbook again. To convert the Newton to the handbook, multiply by the factor 0.225. Whether to divide or multiply, they have given hint here. Multiply, don't divide. So multiply by it, you will get where it is. You will get the force in pound force. So this is the approach one. Coming to the approach two, you guys can do in the other way. Since you are in US, since you are accustomed to US units, you are subconsciously thinking that I have to convert it into US units. You can do it. I will first convert the 70 kg into US units, that is pound mass. So to do that, I will do 70 into 2.205. Where did I get this factor? I'm converting kg into pound mass. So go to the handbook again. As I said, go to the chronology. K is here, so it is kg. So kg to convert into pound mass, I have to multiply by 2.205. So for some of you guys, this thing might be very simple, but for some of you, it might be a bit confusing. That's why I'm doing it very clearly. So 70 into 2.205, I got it is pound mass. So what I'm doing, I am first converting each term, the mass and acceleration into corresponding US units. So coming to the acceleration, 10 meter per second square. The second square is same, second is same for both the units. So I'm not converting anything. I'm converting meter to corresponding feet for the US units. So 10 into 1 meter is equals 3.281. So I got this in 332.81 feet per second square. Now, the final step, is equals to mass into acceleration, which we have studied in your interphysics or even in your BTech while studying the mechanics. So I have taken this term 154 into 32.381. I have multiplied both. So now I got this F value as 5064 in the US units pound force. Is it correct? No, it is not correct. Whenever you are in US, if you want to use each term in US, then you have to use the other factor, that is GC, gravitational constant, that is 32.174. You need not to remember it. As I said, It is mentioned in the handbook in the first page somewhere here. So you can go to that page, you can scroll it. So here you can see everywhere. Some of you asked is the standard value 9.81, even it is here in the both the units. You can take it from there. As I said, it is not simply equal to mass into acceleration. If you are using each term in US, you have to add one more factor. Then you will get the answer 157.5, which we got here in the approach 1. So you can got the approach 1 here. You can notice that now they are same. If you forget this step in the exam, you will get the different answer. You will get the wrong answer actually. So what we, Bhavanam C2C, suggest to you is always use the approach 1. You find the final answer in SI units and then simply multiply by one step, that is 0.225. You will get the answer in pound force. Remember this, guys, for all the subjects, it applies the same.